Hello there, Miss Smart here with today's assignment, which was a review assignment for lessons 6 through 9 from Unit 3 because you have a quiz on it tomorrow. So let's go ahead and get started. So for the first part of the assignment, you actually have a graph to use to solve these equations. And so the first equation, the square root of x is equal to 6. So this is the graph of y equals the square root of x. And so since we're looking for the x value, that means this is the y value. So here's where 6 is on the y-axis. Just follow it over until it intersects the graph, crosses right there, and drop it down to the x-axis. Looks like this is counting by twos. So 30, 32, 34. This is 36, 38, 40. Yep. And so for number 1, we should have x equals 36. And then on number 2, the square root of x is equal to -1. Well, you can see on the graph here that here's where -1 is. And the graph actually, the function starts here at 0, 0. There aren't any values down here at -1. So that's why number 2 is no solution. So what that means is that there is not a value of x that would make this true. There's no solution. All right. So if you were in class today, we talked a lot about how you know how many solutions an equation could have. So before getting to these problems, I'm just going to do a quick little post-it note. I made some posters in class today as well. And so the first thing that I'll share with you is thinking about there's 4 basic functions we've been working with. We've been working with x squared equations. So I'm going to look at the function y equals x squared. Then I'm also going to look at the function y equals the square root of x. Okay, so we've been working with equations that have x squared in them, or something like, even in parentheses, a quantity being squared. And then also same with square root. And so if we look at what they look like on a graph, it'll help us to think about how many solutions could this type of equation have. So for y equals x squared, that's just a basic parabola. Okay, it literally looks like this. And so it's possible for an x squared equation to have 2 solutions. So if it's equal to a positive value, there's going to be 2 solutions. Could have 1 solution if it ends up being equal to 0, or could have no solutions if it's equal to a negative value. So you can see like a negative, that function doesn't even exist in the negative parts of the graph. So could have 2 solutions, could have 1 solution, or could have no solution at all. Now, the square root of x, y equals the square root of x, that function starts right here and goes in just one direction. It doesn't loop around at all. It just does that, and then it keeps going forever in that positive direction. So you can imagine if you have the square root of something equal to a positive number, there's just going to be 1 solution. But if you have the square root equal to a negative number, like down here, there's no solution because it doesn't exist in the negative part of the graph. Now, x to the 3rd equations and cubed root of x equations are actually quite different than these two. You can see for the graph y equals x to the third, it's kind of like this, only one side goes up and the other side goes down. So no matter what you have an x to the third equation equal to, there's actually always going to be one solution. See, this has one solution. It's equal to a negative number. It has one solution. And for the last type of equation we've been working with, y equals the cubed root of x. It looks a lot like this, only kind of on its side. So it goes this way and this way. So a similar thing happens that if you have a cubed root equation, it's equal to a positive number, there's one solution. It's equal to a negative number, there's one solution. So all x to the third equations and cubed root of x equations, they always have one solution, always. There's not a possibility of no solution with either of these. However, with the x squared and the square root of x, there's a couple different possibilities. With this one here, you could have 2, 1, or no solution. And for square root of x, you could have one solution or no solution. Okay? So, knowing what those graphs look like, the first thing that numbers 3 through 8 are asking you to do is determine how many solutions the problem will have. So we've got a square root equal to a positive number. That means there's going to be one solution. And then since it's already, the square root is already isolated, we will raise both sides of the equation to the second power. That gives us x minus 2. 18 squared is 324. So you just add the 2. X equals 326. Okay, on number 4, before you can determine how many solutions there are, you have to isolate the radical part of the equation. So notice that the square root symbol ends right there. The 2 is tucked inside. It's like a present. You can't open it up and take that 2 out until you've been able to square both sides of the equation. You have to eliminate the radical. So before we do that, we move this 4 over because it's outside the radical. So we have the square root of 3x minus 2 is equal to 3 minus 4 is negative 1. And now we can look at that and say, oh, how many solutions is it going to have? Well, I've got a square root equal to a negative number. So if we look at the graph, for square roots, has to be a positive number or there's no solution. So since we've got square root equal to a negative number, no solution. Okay, on number 5, x minus 2 quantity squared is equal to 16. So what I've got is something squared equal to a positive number. So when I look at the graph, I'm going to look at this graph because it's something squared. It's equal to a positive number, which means there's 2 solutions because this is what happens when it's positive. So 16 is a positive number. Every positive number has 2 square roots. So this has 2 solutions, and we find them by square rooting. So when I square root, I just get x minus 2 by itself. The square root of 16 is 4, but it's also negative 4. So I'm going to write a separate equation. X minus 2 equals negative 4. And I solve each one independently. That's a really important step. You don't want to just say plus or minus at the end when you're done, because you're not starting at 0. You're starting at a different place. So when we add this 2 over here, we get 6. And when we add this 2 over here, okay, so this has two solutions. X equals 6 and x equals negative 2. Okay, on number 6, we have the cubed root of x minus 8 is equal to negative 5. So the cubed root graph, here's the cubed root graph, and here's the negative side. So it will have one solution. And so this is a cubed root, which means we'll use the exponent 3 to solve. The index and the exponent need to match, be the same value. So that's why for square root, we squared both sides. For cubed root, you cube both sides. So we get x minus 8. Negative 5 to the third is equal to negative 125. Then we just continue solving by adding the 8. So the equation has one solution. It is x equals negative 117. All right. Number 7 is an x to the third equation. We need to get the x to the third part of it all by itself, and then we can cube root. So add the 7 to do that. X to the third is equal to negative 27. So at this point, we can determine how many solutions there are. So I'm going to look at the x to the third graph. On the negative side of the x to the third graph, there's one solution. So this will have one solution. And so I'm going to cube root. So x is equal to the cubed root of negative 27, which happens to be negative 3. All right, finally, number 8. We've got the quantity x plus 9 being squared. And so for x squared equations, this has to be, or I should say, for x squared, if we've got something squared equal to a negative, that means it's down here. So there's actually no solution. All right, and that is it. So I hope this video was helpful and that you are all ready for your quiz.